Hi, welcome to the Iri Kumi of Week 8. This is Team Yellow Submarine. First is a quick overview of our product, Replay. It is basically a motion capture device that collects information when users do spots. Next, it sends data to our backend server, and after processing the data, we can show the information to our users. For our MVP, we intend to use the processed data to build a simple model that reflects the user's motion. The model can visualize data and make it seem easier for users to understand what they are currently doing. The next part is the recent progress. First, for the basic setup of our hardware, we are using a board, Vamos D1 Mini, which is light, small, and Wi-Fi available, connected to an IMU. To make it portable, we will use a battery shield and a rechargeable battery. To fully capture the information we want, we plan to use 3 of these devices as a set, which binds to users' 2 arms and also the chest. The next part is about signal processing. First, I have added some basic filters to the raw signal collected by the IMU. We can see how here the effect of applying a low-pass filter, which pretty much clears some noise. Next is to quantify the intensity of the acceleration data in order to make it easier to interpret. I have tried the trending and the normalization. After that comes a difficult point. How do we use acceleration and angular velocity to calculate the displacement of objects and find a new position? The basic idea is simple. Since we have the acceleration of x, we just take the double integral of it, and then we get the displacement on the x-axis. Next is to calculate the L2 norm of x, y, and z, and then we get a new position in space. In detail, we also need to take into account the influence of rotation. Before taking double integration, we need to find the linear acceleration using accelerometer data minus the gravity factor, which is influenced by the orientation of the sensors. However, this is just the theoretical method. In practice, it will cause a horrible error because the sensors will produce a lot of noise. Even a small drift in acceleration or angle will have a large effect on position calculation. From the 2 plots here, we can see that if we just simply do double integration, the noise will add up. So is it possible to eliminate these errors? After reading through some papers, I found that it is really complicated to do in real life, and it still requires the high accuracy of sensors. So we need to find a new way to do that. Thus, in order to solve this problem, we will add an ultrasonic sensor to the device. The measurement is more precise, and it is easier to calculate horizontal displacement. However, the rotation of the device in space will still impact the measurement, so we'll continue working on this. The last part is about model building. We have constructed a stickman to simulate the motion of users. We can control the rotation or displacement of it by using some commands at this moment. For the accessibility issues, we have identified blindness, arms missing, paraplegia, and intention tremors. For people with blindness, we can implement a voice guide inside our app that can tell the users what the current data is. In addition, we can have the sensors be independent of each other. And on the app, we match each sensor to a selectable limb. So if a user is arm missing or paraplegic, then the stickman would reflect that. For people with intention tremors, we can have an option to increase or decrease the magnitude of the signal noise reduction so that the users can choose to show or not show the influence of intention tremors. Here's our Trello board for this week. Thank you for watching.